So nomenclature, how to name compounds. So ask yourself the question, is a compound ionic or is it molecular? You know ionic compounds. An ionic compound is made up of a metal and a non-metal. It's a big crystalline structure. Molecular compounds contain only non-metals, you know, those carbon, nitrogen, oxygen, phosphorus, fluorine. Those are non-metals. All right, naming molecular compounds. That's pretty easy. Okay, you use prefixes to describe the number of atoms of each element in the compound. You have to learn the prefixes. Mono equals 1. That is the prefix for 1. Di is the prefix for 2. Tri, the prefix for 3. Tetra, 4. Penta, 5. Hexa, 6. Hepta, 7. Octa, 8. Nona, 9. And deca, 10. Now you can come up with your own little memory tricks for these. Mono, imano, one-on-one. Triangle has 3 sides. A tricycle has 3 wheels. Penta, the pentagon has 5 sides. Hepta, I got nothing for hepta. Nona, I'll leave you with nona. A 9. Die, there's 2 dice. 2, tetra. Tetris, you have 4 sides to a box and or a square, and you're trying to get things to match up. Hexa, 6. Octa, octopus, has 8 arms. Deca, decade, has 10 years. So here are the rules. When you're naming molecular compounds, and remember, molecular compounds are composed only of non-metals. So as soon as a metal creeps in there, you're not talking about a molecular compound, you're talking about an ionic compound. So non-metals only. Don't use mono for the first element in the compound, in the name of the compound. If the compound is binary, that means there are only 2 elements. So for instance, here's our compound. This is carbon, and it's got 2 oxygens. So the formula is CO2. So we would call it carbon dioxide. Di, because there are 2 oxygens, and IDE because it's a binary compound, meaning there's only 2 elements in the compound. I know there's 2 oxygen atoms in the compound, but there are only 2 elements in the compound. That's what we mean by binary. Carbon, oxygen means it's binary. If it were carbon monoxide, that would be carbon and 1 oxygen, not 2, and so we would call it carbon monoxide. Never use mono for the first element. Okay. Clicker question. Which of the following is true, the classification of HCl and NO2? So the first question is, are they ionic or molecular? Okay, sorry guys, I had to turn that light out. It was in my face. I used it so that you could see the models that I was using. So let's take a look at HCl. Hydrogen. Hydrogen is a nonmetal. Chlorine is a nonmetal. It's a binary compound, so this would be hydrogen chloride, and this is definitely a molecular compound. This is, you've got nitrogen, which is a nonmetal, oxygen, which is a nonmetal, and so this would be nitrogen dioxide, which is also a molecular compound. Okay, nonmetals only mean that it is molecular. These are both binary compounds because you only have 2 different elements. Yes, I know you have 2 oxygens here. That doesn't matter. You just use the prefix di for the oxygen. And remember, never use mono for the first element in the compound. So this is, the answer is D. HCl, hydrogen chloride, is a molecular compound. We would actually, if we name this correctly, we would call this hydrogen monochloride, but common usage for this particular compound, nobody says hydrogen monochloride. We just say hydrogen chloride. In most molecular compounds, you would use the mono for the chloride. All right, so this is a molecular compound. Nitrogen dioxide, NO2 is a molecular compound. So this is just a periodic table to remind you that you have over here for HCl, you've got a blue guy, hydrogen, and you've got Cl, which is also a blue guy. These are both nonmetals, so that's a molecular compound. Nitrogen and oxygen, they're both nonmetals. That's a molecular compound. All right. Naming ionic compounds. This is a harder job. All right. The first question you want to ask, is the metal in the compound of known charge? That is the metal from group 1, group 2, is it aluminum, zinc, or silver? And if the answer to that is yes, here are the rules. Just name the metal, then name the nonmetal. Use the "ide" ending if the compound is binary, if there are only two elements in the compound. So for instance, this is a representation of sodium and chloride ion, and so this is going to be sodium chloride. All right, we'll get to the polyatomic anions in a little bit. Okay, so here we go. Is the metal in the compound of known charge? That is the metal from group 1, group 2, is it aluminum, zinc, or silver? So hopefully you can see this fairly well. So here are the group 1 and group 2 elements. These guys right here. Lithium, beryllium, sodium, magnesium, potassium, calcium, rubidium, strontium, cesium, barium. You're really not very often going to have to worry about francium or radium. They're radioactive. You guys aren't going to use them very much. And beryllium, you'll find some uses for beryllium, but really anything in here. These are group 1, group 2, and group 3. And the reason you don't have to name the charge on the metal is because all of these in group 1 are +1 cations. All of these alkaline earth metals, these are all +2 cations. So you only need to name the metal and then name the nonmetal. Now, the same is going to be true for aluminum, zinc, and silver because they all have known charges, and it's the only charge they will typically assume in a normal compound, and that is +3 for aluminum, +2 for zinc, +1 for silver, and it just goes straight down the line on the diagonal. All you have to remember is aluminum, zinc, silver, 3, 2, 1. Say it with me. Aluminum, zinc, silver, 3, 2, 1. So for instance, if I had aluminum and chloride, so this is aluminum chloride, that's all you have to say. So this would just be aluminum, or as the British say, aluminium. Okay, so this would just be aluminum chloride. And then you could have zinc. This would be zinc bromide. Okay, or silver, you're going to learn about this, nitrate. Okay, so if you have a group 1 metal, a group 2 metal, aluminum, zinc, or silver, all you have to do is say the name of the metal, then the nonmetal, use the IDE ending if the compound is binary, and then the appropriate polyatomic anion ending if you have a polyatomic anion. And this is the nitrate anion. We're going to learn about that in just a minute. Naming ionic compounds continued. All right, this is the harder part. This is actually part 2 for ionic compounds, and this is going to be a little bit more difficult. So here we go. Naming ionic compounds continued. Just remember that if it's ionic, it's a compound composed of a metal and a nonmetal. All right. Is the metal in the compound of known charge? That is the metal from group 1, group 2? Is it aluminum, zinc, or silver? This time the answer is no. So you have a different set of rules if the metal in the ionic compound is no. Name the metal. Designate the charge on the metal ion by putting the charge in Roman numerals in parentheses. Name the nonmetal. If the compound's binary, it gets the IDE ending. And if the compound isn't binary and you have a polyatomic anion, you have to use the correct name. So here we go. First question. Is this compound, is it ionic or molecular? Now, all you have to ask yourself, is this composed of two nonmetals, in which case it would be molecular, or is it composed of a metal and a nonmetal? Well, sodium is an alkali metal. It's a group 1 metal. It's right underneath lithium. It has an atomic number 11. Here is oxygen, which is a non-metal. All right, so this is a non-metal. So this is a metal and a non-metal. So this compound is ionic. Okay, next question. Is this metal of known charge? That is it group 1, group 2, aluminum, zinc, or silver? Well, yes, it's group 1. So the rule is name the metal, name the nonmetal, and if it's binary, it gets IDE for an ending. And that's if it's binary. And binary just means 2 elements. Okay. All right. That's not the way to spell elements, but I'm going to leave it to you to fix that. Okay. So here we go. So this is going to be sodium. This is oxygen. So we just give it the IDE ending. And so this is sodium oxide. We don't need to name the charge on this because we already know what the charge is. If we didn't know what the charge is, we would use the nonmetal to tell what the charge is. And I'll show you how to do that in just a bit. Polyatomic cations. Here we go. It's a long list. There it is. This is the ammonium cation. It's a cation because it's got a positive charge. I'll go ahead and draw the structure for you, and you'll learn how to do this in the second part of the course. This is the Lewis structure for the ammonium cation. It is polyatomic. Why is it polyatomic? Because it has many atoms. The prefix poly just means many. Okay? So it has multiple number of atoms. It's a cation. It has a positive charge. Ammonium cation, and you're just going to have to remember the ammonium cation is your polyatomic cation. Now, your polyatomic anions, that's a bit of a longer list. Notice this is page 1. Here we go. All right. We've got acetate, azide, cyanide, hydroxide, permanganate, thiocyanate, dichromate, and peroxide. All right. So there are a few of these that you'll need more than others. So acetate is the polyatomic anion. for acetic acid and sodium acetate. You're going to use it a lot, so acetate is definitely one that you need to remember. Now, azide is an interesting anion, and it is the active ingredient in airbags that you find in cars. Sodium azide is what's used in airbags, and you'll see me refer to it. So it's it's something that you might want to pay attention to because it's in your environment. Everybody here probably at least rides in a car, if not drives in a car, and airbags in modern cars are everywhere. So sodium azide is the active ingredient in those airbags. You'll learn how to use those, or how those work, when we get to gas laws. Cyanide. Everybody needs to know what the formula and the charge of cyanide is. Why? Because it can kill you. And you always want to know something about things that can kill you, and cyanide is definitely one of those things. So you need to know the formula, you need to know the charge. Hydroxide is essential for your understanding in chemistry. This is the active ingredient in bases. This is what it makes a solution what we call basic. Okay, so you need to know about hydroxide. It is a polyatomic anion, OH, with a -1 charge. So this is definitely one. This is one. Permanganate is an oxidizing agent. We use it quite a bit. You're going to see it again later in the course. Thiocyanate, anytime you see the prefix thio, you're thinking sulfur and smelly, because it generally is, but thio is the prefix for sulfur. This is dichromate. You'll see all of these guys, but the three that I've got circled up top are going to be the most important. Peroxides. Peroxides are in your environment, definitely something that you're going to want to pay attention to. You're going to see them around, but I'm not going to emphasize peroxides at this point. These three, I absolutely insist that you know the formula for, the name for, and we're going to use them quite a bit. If I were to then look at some others, I would say, yeah, you might want to pay attention to azide. You're going to see it later. You may wind up using permanganate in the lab as an oxidizing agent, and usually in the form of potassium permanganate. It's purple. Thiocyanate, not so much, but remember thio means sulfur. Dichromate, not so much. Peroxides, these guys are in your environment, something that you are going to want to pay attention to. I bet you have hydrogen peroxide in your medicine chest. All right, polyatomic anions too. These, you just need to know them, guys. You got to have these in your lexicon of polyatomic ions. Now, I want you to remember that they all end in ATE. They all have this in common. And people get very confused with the naming of polyatomic anions and the scheme, the number of oxygens and how they relate to each other. These are all called the oxo or oxyanions. And that's obvious. They have oxygen, and they have various numbers of oxygen atoms in their respective formulas. So you need to know all of these: chlorate, nitrate, carbonate, chromate, sulfate, and phosphate. You need to know the formula, and you need to know the charge. You cannot get along without knowing the formulas. That is, how many oxygens do they have? What is their charge? Okay, and their charge will be the same without respect to the number of oxygens that they have when we go through this naming scheme. All right, hopefully that's clear. You need to know all of these guys. I'm going to focus on chlorate. It's an easy one to use in the naming scheme.